Look, 2 o'clock. Terry, shall we start?
All right.
Welcome you all. This is the second of our conversations. This one is about the science behind Mānuka Honey, namely, why is it so special? And we'll get there. So just as a bit of administration, if you want to ask a question, and we do invite you to ask questions, please go to the bottom of your screen where you've got participants. If you click on that box and you look at the bottom of it, you'll see a little raised hand. So you're more than welcome to ask questions. Just put your hand up and Dr. Braggins should be able to answer your question.
So you've got to type in a message, type in the question.
Or push the hand and the hand will pop up.
Right, okay.
Then the team can let you through. So it's fairly simple to put your hand up, just like the days at school. Please, sir, may I ask a question? So just before we start, just I understand on the weekend, a beekeeper, Bruce Robinson, has passed away from Haynes Apiary. He was actually quite significant, and I got to know him a little bit, and that he helped us a lot with the Mānuka ID project. I remember when we did that project, we did the collecting of the nectar. Then we also got some samples from various beekeepers, and we had good traceability. And we went, and he allowed me into his factory, and he allowed me into his retention samples, and had great traceability to where they came from. And you said those samples there were as good as the ones we actually collected to the field. There was a clear match. So Bruce did open up what he had available to us, and also had a significant input into the Mānuka ID project a few years ago. So my thoughts to Bruce, to his family, and he was a significant character and helped a lot with the industry. So yeah,
yes, very good.
Fine. So now into the key part. You're Dr. Terry Braggins. Your position at Analytica is?
Well, I'm just a person working there. I was one of the founders of Analytica, but I've stepped back from the managerial role and working on special projects, and in particular the R&D side and honey, and developing new methods and managing some of the initiatives there.
So we reference science a lot, and we actually quote it's science. What does it mean to you?
Science is the discovery of new things, and the proof of a concept, or the proof of a thesis or a hypothesis. So it's backed up by research, and sound research, and research that you start out with not having any predetermined outcome, and you just observe the results and comment on them, and then make conclusions.
So the scientific process of research and publication, review, gives you a level of confidence?
Well, certainly does. I think a good scientist should always be sceptical of other people's work and sceptical of your own. And that's one of the reasons why there's peer review, because you try not to be biased, and you try to look at things in a systematic way, but it's always good to have other people look upon your work and make comment, because we're not perfect, and we can't see everything all the time.
All well and good, but the industry is demanding of answers. They look towards the scientific community to invest in this industry. They look to the scientific community to find answers to various points or issues we'll get into. So they're looking to this body, this reference point, to say, here's some answers. So the importance of the science is to the best we possibly can, is provide answers so we can invest, move forward, and meet consumer expectations.
Certainly. So I guess the science and the research and development can be broken up in two broad areas. One is basic research, where you're just trying to discover something completely new. And then the other research is more applied research, and probably more of the work we do for the honey industry in the research area is applied, where there is a problem and we look to solve it, or there is the potential to improve a product, and we look for answers to that and how we can build knowledge to create an opportunity or a uniqueness, for example, with Mānuka Honey.
Fine. So you described the uniqueness of this Mānuka Honey. If I remember a few years ago now, when I first met you, I sort of bowled into your office, very similar to very close to where we are now. And I said, we have this issue. We really don't know what Mānuka is. And there's three things that came to my mind. If you don't know what it is, you don't know what it does. If you don't know what it is, you find it difficult to protect. If you don't know what it is, you can't really define or ensure the standards meet consumer expectations. So the first principle of all this science would be, in my view, understanding what Mānuka is. And we did the Mānuka ID project.
Certainly.
And so if we work through this in a sequence of events, knowing what it is has helped us to be able to define what it possibly can do. Knowing what it is has helped us with the protection of the term Mānuka honey. If you don't know what it is, you can't protect it. And also with the future work over standards. So we're more in line with overseas expectations. That would be reasonably correct.
Yes.
So if we look at the honey industry itself, and I've been listening to you even over the last few days, the international expectations of honey is rather skew with to historical. They haven't really taken into account the variety of plants, the variety of honeys, would you say?
So my perception of it, and it started really with Codex Alimentaris, that is really a voluntary, an international voluntary organisation for the safeguard of food and the sale and trade of foods. And as part of that, they have some regulations and definitions about Mānuka honey. And years ago, when that was set up, it was to cover honeys that were about at that time. And so most of the honeys then were sold fresh. So they were harvested in the same and sold in the same season, obviously for cash flow reasons. Why keep honey if you can sell it today? But with the advent of Mānuka honey, it was found with the DHA, high levels of the unique DHA that are converted into MGO, that time and temperature is needed to change the DHA into MGO. But the consequence of that is that Mānuka honey is aged. So the question is, are some of the tests and criteria and definitions that have been determined through Alimentaris or Codex in the past, are they relevant for New Zealand Mānuka honey and perhaps other non-European or Northern Hemisphere honeys? Because over more recent years, honeys from South America and Africa and Asia are becoming more popular. And is Codex relevant for that now?
And if we go back to the time when we talked about the Mānuka ID project, there was that traditional argument that, well, we have to use pollen analysis. And that's probably where it all started. And we said, well, no, this honey's in a bush, it's complex, it's a complete biodiverse environment, and to really analyse it, we're going to have to use different techniques. Do you want to describe the techniques that have come about over time to define what is Mānuka honey?
Sure. So first of all, with pollen counting, it was assumed that a certain proportion of pollen found in honey was the same as the proportion of nectar-derived honey. And that's not necessarily the case. Some bees go and collect pollen and others go and collect nectar, and some by just being out around the flower inadvertently pick up some pollen. And they visit different plants. So you could imagine that perhaps pollen isn't a good indicator of the monofloral nature of a honey, although that's what has been done historically. And it wasn't until recently, the last, say, 5 years, and where we became involved, that we were looking for an alternative way of determining the monofloral nature of a honey. So one of them is to look at the chemical profile of the nectar and then the chemical profile of the honey. The assumption being is that they should be the same if it was a monofloral honey. And considering that, there's the opportunity or the circumstance that there may be some chemicals that are found in nectar don't relate all the way through to the honey, because the bee might consume some of those chemicals or convert them to something else. So that was the premise of what we thought we could do to set up a new technique. And we used a thing called liquid chromatography mass spectroscopy. So the chromatography separates out the components within a mixture, and the mass spectroscopy can identify the different compounds. So when we applied both techniques to the nectar and also to the honey, we found thousands of unique molecular features, or in other words, chemicals, particularly in Mānuka and Kānuka honey. And when we compare the different monofloral honeys, we find that the Mānuka and then Kānuka have the most abundant different chemicals in honey, and the one that has least abundant chemicals seem to be clover. So that was advantageous for us, because then we had a lot of potential chemicals that we could use to characterize the honey. And thirdly, we used a technique called multivariate analysis, which is a statistical method and a fingerprinting method. So it's very much like comparing fingerprints of humans. There's not one point that may be different, but collectively over the whole thumb, there is enough evidence to say that one person is different from another. So similarly with honey, you can use a chemical profiling method to distinguish between different floral types.
So let's delve into that a little bit more, because there's been a lot of statements about how unique this honey is.
Mm-hmm.
So I remember a few years ago I was in the UK, and first time I saw some NMR work, and like you, I saw virtually a flat line for clover, and yet Mānuka was up and down. It had all these peaks, and it looked like a heartbeat. It looked like a living product that had some values to it, maybe not. But there was a lot of it was absolutely unique than any other honey they actually had analysed using the NMR. To what level do you think it's unique? Is it worth that, having that comment behind it? Is Mānuka unique?
Well, it appears to be. Admittedly, we haven't compared every honey floral type that exists in the world, and I'm sure there are some honeys that have a prolific number of different chemicals in them. But within New Zealand Mānuka seems to have a large number of different floral compounds. So that in itself is unique. But then, so that's chemically unique, but then there's biological activity uniqueness. And we know that most honeys have some sort of antibacterial activity. And usually that's caused by peroxide content and also the osmotic pressure of the honey, because it has high sugar content. So it pulls moisture out of bacteria and prevents them growing. Bacteria love to have moisture so that they could grow. And so the water activity within a sample encourages growth. So if you've got low moisture activity, then bacteria won't grow. But as Peter Molan found, is that even if you get rid of the non-peroxide, or the peroxide activity, there is still a biological antibacterial activity of Mānuka honey. And that's the most unique thing about it compared to other honeys in the world.
And do you think there are other unique factors that have the emerging research behind it?
Well, more research coming out are looking at things like antiviral or anti-inflammatory, encouraging repair of wounds and cuts, etc. So that is evolving by the day. I see new research coming out regularly, people investigating those properties.
So you would say, one, this is a unique honey. Two, ranked against all the other honeys in the world in terms of research, my view, contemporary research, it would be ranked high, the highest?
Yes, it would be. It's very high. And what I have observed over the years, that because of its uniqueness and because the other uniquenesses of it's one of the highest valued honeys in the world, of course, other countries are looking at their honeys and seeing if they can come up with something as unique or more unique so that they can increase the value of their product. So you're starting to see other research being done by other countries on other honeys.
So I'll just write that down. We'll get to that point later. So in my time, I'm looking at different honey products, for example, royal jelly, bee pollen, propolis, honey. Internationally, I think royal jelly would be the most research targeted. Then propolis, pollen, and honey. The research Peter Molan started and where this industry has taken Mānuka honey has flipped that around, has taken from what was the lowest level of a honey product that potentially had some attributes or values and flipped it to the top in terms of apitherapy. and turned around and said, shifted the ranking around quite a bit. It's put Mānuka honey near the top, right up with raw jelly, and then, as I said, propolis, bee pollen, and so forth. So that's, for me, the work that has been done by researchers like yourself, Peter Moland, and there is a Rose Cooper. There's actually quite a bit of international collaboration around and body of evidence that has cross-referenced the research around this unique honey. So that should give an industry a lot of confidence.
Yes. Professor Kato in Japan has been doing a lot of very good work and looking at leptospirin, for example, to see what potential bioactivity it has. So, as you said earlier, you don't know what you've got until you investigate what's in it. And obviously, the DHA and MGO story is at the forefront at the moment. But as more and more knowledge is gained about the composition of honey, particularly Mānuka, and we identify the chemicals involved, then we can start to look at those chemicals and see if they have some type of bioactivity as well.
Yeah, before we get down to some other unique issues around this Mānuka honey, one of the notes I just wrote to myself was reminding me about the other work you've done on identifying those unique characteristics. And I remember listening to you a number of times in different symposiums, and you talked about the peaks, these markers that are the high, in other words, they're abundant, and they're singular, in other words, they're separated, they're not confused in a whole mountain of other chemicals. It actually is quite clear it's abundant, they're stable, they're strong. Do you want to define what makes a good marker that you can say, yes, I should use that, and maybe one or two others to define this product?
All right, well, if the purpose is to identify the authenticity of a honey, for example, Mānuka, and to distinguish it from other honeys, then you would want a chemical that's unique. That's the first thing. And as I said earlier, the way we do that is look at the nectar, and if it's unique to nectar of that floral type, then that's a good marker, potential marker. The second one is looking at the concentration of it. As I said earlier, there are thousands of compounds in some of these honeys. It's little point looking at something that's the noise or just the bread, the crumbs, because it will be hard to see them in all honeys. So you want something with a reasonable concentration. And thirdly, that it's quite easy to be able to detect by a particular instrument method. And it's reproducible. So they are the main features that you would be looking for. Another one would be its stability. So is it stable over time, or is it stable at different pHs within the honeys? And is it repeatable for the floral type? And is it stable against temperature increase? So they are the other attributes you would look at.
Just one of the points on stability. I used to run a few stability programs in the nutraceutical field. We put together various rooms under different times, temperatures and humidities to be able to determine it. For me as a manufacturer, I thought, well, that was my responsibility. I would determine my shelf life of the product based on how stable it was within the container it was in, whether it was in a capsule, whether that capsule was in a foil, whether that foil was in a bottle. The stability part of a product was in my hands. If I was selling a chicken in a supermarket, probably the time frame's rather less, but if I was selling a very dry, shelf-stable product, the extension would be quite long. If I'm quoting a bioactivity, that's for me to be able to measure. So from my time, I've always had a little bit of trouble of the stability side, because for me, I've always thought as a manufacturer, that was for me to be able to prove and put the appropriate shelf life on it, just as a discussion.
Yeah.
So we've used a technique that covered the biodiverse environment of New Zealand, because that's the way we want it. We don't want massive fields, and it's part of the New Zealand environment and the other trees and the diversity we want within our honeys. So we've used a technique that covers that. We're in Europe, big long fields and all the rest of it. There's fields of clover or thyme or whatever else. It's very easy to go a pollen analysis to do it. Fit for purpose, an obvious environment. New Zealand, significantly different. But we also wanted to back up the journey of how we measure this honey is also how we can rate this honey. So using the same tools is going to be quite important in terms of getting us that. Part of the work you did also identified markers that were absolutely unique that have been protected.
Mm-hmm.
Do you want to go into that?
Yes, certainly. So I mentioned earlier that there are thousands of compounds found in Mānuka honey. So, I mean, we could measure them all, but it would be very expensive and take a long time to quantify them all. So the next is to pick the best of the bunch, and I think we had about 600 or so compounds that we thought were unique to Mānuka. And even though that number, it just seems a lot to handle. So we cut that down to about 20 that fitted the criteria I mentioned earlier about the uniqueness, the concentration, the reproducibility, etc. And so we have applied for a provisional patent on those, and in the event in the future that they could be used as bioactive materials, but also as discriminators for the uniqueness of the honey. In other words, an identifier for Mānuka honey.
So we're in a competitive world, and as you said, other people will be looking for honeys. Maybe you can plant this Leptospermum scoparium anywhere in the world, and hopefully we are able to protect the term. We're putting every effort we can into that.
Mm-hmm.
So, but there's this other thing. If you can protect this term, and you can also protect what are the key markers you use to define it, you could help protect, secure, and advance an industry through that. So you've got that framework available through your science, through using a few legal processes to enable an industry to feel comfortable in its space, that's clearly defined. It's able to say, this is our space and no one else can call it and take it. To be the champagne of honeys of all time. So that for me is the value of the science that you started with, and the team that worked on the Mānuka ID project.
Certainly.
And yes, there's the ability to hopefully to be able to fund an industry through that as well. So that's an outcome. I want to head now into some of the complexity or complex issues around Mānuka honey. And there's quite a few because it is so unique. And let's talk about just some background on what DHA is and MGO and how they convert and the issues around that.
Certainly. So the uniqueness of Mānuka nectar is that it has this chemical DHA or dihydroxyacetone. And the MGO or methyl glyoxyl is not found in the nectar. It's only found in the honey. So it's not until the bee takes the nectar to the hive that there's a chemical reaction. It's not a biochemical reaction, but a chemical reaction that slowly converts the DHA into MGO. And that's temperature dependent. So the higher the temperature, the faster that reaction will occur. The chemicals are very similar. There's only a difference of a water molecule being removed from it to change it. So it moves from a unreactive or non-biologically reactive compound into a reactive one. And the methyl glyoxyl is responsible for the antibacterial activity, or at least the majority of it. And that process, as I said, is temperature and time dependent. The downside of wanting to rush that reaction through quickly is that another aldehyde, or HMS, hydroxymethyl furfural, increases. And unfortunately, if it goes above 40, then people on the international markets don't really want to buy it. So in the case of any advice to mature a honey is really low and slow. In other words, low temperature for a longer time rather than a higher temperature for a shorter time will give a better quality honey.
So there was the reason why I believe the international community has picked this level of HMF is ensuring all the other enzymes and all the other natural goodnesses of this honey are maintained. Is that a fair assumption?
Yes, they used it as an indicator of temperature abuse. And as I said earlier, the main thing done by the industry was to sell their honey young. So their perception of a honey that's not advisable to consume is something that's been kept for probably 2 years at around 23 to 25 degrees. And the result is the HMF will go up.
So we're in a bit of a quandary here, because if I can sell my honey for more value, if the HMF goes up and the DHA obviously will convert.
MGO.
The MGO goes up, DRJ drops down, and our HMF increases.
Mm.
So, that isn't, as a behaviourist would say, you're reinforcing values there that aren't probably best for the honey. So it's trying to create a different way of looking at it. Do you think that's needed?
Yes, possibly. I mean, it would be better for the New Zealand Mānuka honey industry if some of these markers used for identifying aged honey were changed. And another one is the diacetase. Diacetase is an enzyme, it's a biological protein, and it will deactivate if the pH is wrong or the temperature is too high. So if the temperature goes above 72 degrees, you can knock the enzyme out pretty quickly, or at least its activity. But you could argue, well, is the nutritional value of the honey changing just because the diacetase enzyme is deactivated? It's still a protein, it's still got the peptides, it could be fine. So the argument is it a good indicator of temperature abuse of a honey? And it may well be some other test. And similarly, HMF could be another one where the levels are adjusted for a matured honey. You will all appreciate that a good red wine has been matured. It's not something that you would drink just in the first year of harvest unless it was a Beaujolais. And so the perception could well be the same for Mānuka honey, where a matured honey is something that we want to consume rather than having it fresh.
So because of the uniqueness of this honey, we've got a fair amount of work to do internationally to see that it still fits in its right place, given those, what you described with the HMF and diatase, that it's not loses its value because of its uniqueness.
Certainly we do. My involvement in Apmondia and also the ISO organisation that looking at bee products and honey standards, we're getting pushback on the attributes that Mānuka honey is showing. In other words, low diacetase, higher HMF, C4 sugars going up, and we're working to try and push back on that itself. But there is recognition within the international industry that they will allow a change to the rules, or at least a derogation or a deviation from the rules, as long as it's supported by research.
And there's a counter to it, though. If we open this door up where there is a change and we can increase levels of HMF or maybe C4 sugars and diatase, but also doesn't open up the door for abuse. So we've got to be equally careful that as an industry, that it doesn't say, it doesn't matter, it's okay, mate, I will do A, B, and C, and we'll increase the heat and we'll get the MGO value up, and that's okay. And we have taken samples from the international community, from various territories, and it says we also need to be careful there as producers to ensure that we're doing everything we can to maintain the quality aspects of the honey, and not use the vehicle that says, well, there's variations to it, it's okay. So there's that balance between getting the science right, that says this is unique, there needs to be those accepted changes, particularly given where Codex came from and driven from a European point of view, versus a wholesale targeting or abuse of the product.
Certainly, and I can give an example from some research we've been doing here at Analytica with the diacetase and incubating honey samples at various temperatures, and just generally that if you incubate at say 20 degrees, after about 18 months, there won't be much diacetase level left in the honey. But if you change that to 34 degrees, then it's a matter of weeks and the diacetase is gone. So therefore, I've calculated out that if you heated the honey at 50 degrees for a matter of days, you can get rid of all the diacetase. So you've got to be careful of how you handle the honey, and you can't stand behind it and try and argue that, Mānuka honey is unique because it has low diacetase anyway when it's fresh. Well, that may be in some instances, but not in all, I believe. So we just have to be careful that we don't hide behind some false information.
I do remember we did, I think it was out of Singapore, some samples at 400, 200, 120 HMF,
Yes.
which clearly is not poor shipping or stuck on a shelf in the sunshine. That's clearly, it's been heated along the way.
That's right, and you don't know what level the honey was in terms of HMF when it was exported, but it's like the saying, rust never sleeps. And if it's in the market in the Middle East on a retail shelf sitting at 30 degrees, well, it's just going to grow and grow and grow. So distributor or exporter of honey has to take into account the potential for the honey to keep on growing in terms of HMF and diacetase going down, but also the shelf life of MGO. Has it reached its peak already when you've sent it out, and is it just going to carry on decrease over time, or is there some potential still left in it to take into account that storage at retail?
So you could argue if we sell a $5 ice cream to an overseas market that has high temperatures, we should be able to sell a $150 bottle of honey.
I would say that's a good thing to say, yes.
Fine. Let's get into one of the more complex topics, and that's C4 sugar. You've just, along with your colleague Anatoly, published a paper on it. I believe it's been put out in an appropriate journal.
Yes.
Do you want to take us through the paper? I reread it last night, or the night before actually, over a bottle of red wine, and it stuck perfectly in my tiny little mind. But can you actually take us through it?
Okay, the red wine stuck in your mind?
Oh,
yeah. Okay, so indeed, and most of you will know that particularly for honeys with high MGO levels that have been stored, that the C4 sugar levels tend to increase, and the research has shown with Karen Rogers doing it, and also here at Analytica, our own research has confirmed that if you incubate honey with high DHA, over time, that as it converts into MGO, there's an apparent increase in the C4 sugar levels. And this, in these situations, is mainly due to one of the components of the test, which is the protein. Its 13C value tends to go more negative, which makes the difference between the protein value and the honey value get greater. And thus, when you calculate out, there's an apparent increase in the C4 sugar. And yet the honey value for the 13C value doesn't change. When someone adds C4 sugar to honey, the protein value should stay the same, and the 13C value for the honey itself would increase. But in this case, with Mānuka, that doesn't change. So it was believed that the MGO was binding onto the protein and causing some sort of change in the test. But more recent research, as John has indicated, of Anatoly and I, that was co-funded by UMFHA, has showed, yes, indeed, there is binding of the MGO to the protein, but that just is an initial binding and it stops. So even though the C4 sugar keeps changing, the amount of MGO bound is consistent and it doesn't keep increasing. So just a very simple conclusion to it is there must be something else in the honey, this compound X, that is causing this shift and is affecting the test.
So we've got a couple of questions, and this is related to C4 sugar. In short, when are we going to go into bat internationally to deal with the issue of C4 sugar? I think the answer from a UMF point of view is we need to go into bat as a collective industry, that we're all coming off the same song sheet. So that's working with the other two industry groups over it, ensuring that we've got the research that can stack up internationally to do that. What role are you playing in that at the moment, young man?
So, as I said, I've been involved with the Apimondia fraud working group and also with the ISO standards committee, both in the honey and the propolis. And the discussions I've been having, and also with some of the major laboratories in Europe, particularly in Germany, who are experts in C4 sugar testing, is that they recognise there is an issue that we have, and they are beginning more and more to believe the research findings. But there still needs to be a few more experiments to be done to conclusively prove what is happening. We know it's happening, but we're not quite sure why. And what's the chemical mechanisms that cause this change? And I've got some experience up my sleeve to do. And when we can find the time and the funding to do it, then we'll get that underway. And I believe we're close to identifying what that is. But that's really what is required to finally get it over the line, such that two things. One, the international people who make these decisions and AOAC, etc., will believe us, and then there's a derogation. But as John mentioned before, it doesn't necessarily exonerate us, because there's still the potential, using the same technique, to actually adulterate the honey with C4 sugar, and we won't be able to tell the difference between this false positive C4 sugar and a true positive C4 sugar. But if my research comes out positively, then there is the opportunity to modify the method such a way that we can distinguish between the two. We can distinguish between the false positive and the true positive. And once we nail that, then the industry will be able to argue with our international markets to accept more readily the Mānuka honey with higher C4 sugars.
Just on that note, the international market is not exactly correct. You can't put your finger on an international market. One would say there is groups within Europe. That there's a very strong body of knowledge within Germany that has their own ways and techniques. There is a difference in views in the UK on some of those aspects. There's a significant difference of views in China, for example. And they are for various reasons, and they have their interests. And there's also not an open door, but a totally different approach even in the USA. And again, an approach to protect their own honey industry within South America. So to put your finger on a one world view, it's not really that as easy, is it?
True. There's a wide divergence of interpretations around the world, but I know in the New Zealand industry there are a number of companies that suffer from this apparent C4 sugar issue. And I might say there's recognition amongst the laboratories around the world that the AOAC C4 sugar testing method is not ideal, and it is now slowly being replaced by the NMR method, although in saying that, that can't detect low levels of adulteration. So the consensus these days within the laboratories is it's a multidisciplinary approach, that the C4 sugar, a modification of that method, the NMR, and now high-resolution mass spectroscopy looking at profiles of different sugar syrups, and collectively all that data will help people conclude if the honey has been adulterated or not. The downside of that, it becomes very expensive to do all those tests at once, and whether the industry can accommodate that is another thing.
So the other question here is this honey with an apparent C4 sugar. There is the issue of the potential that it's part of the chemical profile of this honey that's affected the change. There's the argument that says that it's been adulterated, which implies intent. But there's also the other argument, again, given, if I was a beekeeper in a New Zealand environment and I was in we have a very short window of opportunity here. We've got 4-6 weeks. It can come down to 2 weeks where I've got to build all my bees up. I've got to get it targeted and I've got to get them in. And if it rains or it's windy, and I need to keep my bees alive and all the rest of it. There is, in my view, there's no intent, but there needs to be an understanding, again, this is a unique part of being a New Zealand beekeeper. that is not completely like in a Europe context where I put it out onto the field, or in China where I walk up and down the fields literally with the beehive on my back, or I'm in an environment with the constant flow of nectar in South America, whatever else. We are unique, it has unique, and if we do want this honey, we're going to have to learn different ways of looking at this honey, because there was no intent from the beekeeper. It was it was this season. Is that a fair argument? Or?
It is, but there are consequences. So if the prime aim is to get the highest quality Mānuka honey, so in effect that means the highest levels of MGO. In doing so, there may be a compromise where the beekeeper has to pull the frames out of the hive when they may not all be capped. And if that's the case, then the consequence is higher moisture content. The consequence of higher moisture content is that there is a greater chance for fermentation. If there's a greater chance for fermentation, then there's a tendency to pasteurize the honey. However, in speaking with these organisations, Apimondia and ISO, etc., they are quite adamant that pasteurisation must not occur, nor must the reduction of the moisture content of honey occur. So that is a major challenge for New Zealand. If we can't prove that it's legitimate to remove moisture from Mānuka honey and or to pasteurise, then if overseas markets again want to stipulate these rules, then there is going to be a major pushback onto New Zealand markets and the ability to export products. So the moisture content removal and also the pasteurisation are becoming major talking points at the moment in these organisations. So the New Zealand industry must give careful consideration to that, either by challenging some of these comments around the world and these regulations, or by changing beekeeping practices. And the consequence may be not as pure Mānuka honey, perhaps. I don't know.
So we have a question. Kirsty, do you want to let them in, please? Yo? From True South, I believe.
Hello, True South. If you could accept the unmute invitation to unmute, please.
Answer that one too.
Yep. No, we'll carry on. Terry.
Oh, they're here. Just a minute. Sorry, they're unmuted.
Okay. Speak, oh wise ones.
Yep. I was wondering about the MGO when you're talking about the MGO, but I think you've answered my question. Thanks.
Are there any other questions, Kirsty, from that? If not, we'll go to the chat line.
Just the ones that are listed on the chat that I've sent to you.
Right. Do you want to go for those, Terry?
Mm-hmm. So there was a question, if all tests meet the MPI markers tests, has there ever been a failure in the DNA test to make it a multi or non-Mānuka honey? So we have observed and that for some very high MGO honeys that have also usually had a high HMF, so you can assume that they have been stored for a long period of time or a shorter period at a higher temperature. And from my incubation experiments, that over time the DNA levels will decrease, and to a level that some of them ultimately fail. So the DNA is broken down and you can no longer detect it. But it's a small percentage, and it really depends on what the starting level of the Mānuka DNA is. We notice from the tests that have been done this year that overall there seems to be a lot more Mānuka pollen and also Mānuka pollen DNA CQ values in the past, the lower value, which means the highest concentration of DNA, that was seen as at most about a 20 or an 18. But this year we've seen a number of honeys that have a CQ of 15. So that's from an 18 to a 15, that's 3 orders of magnitude or 1,000-fold more DNA in it. And that relates to what we see from pollen counting, that there are honeys coming in with extraordinarily high count of pollen. So the bees are picking up more pure nectar, and at the same time they're picking up more pollen. But there are cases where very good Mānuka honeys have failed because the DNA has literally gone off.
And is that the extra pollen from my reading, with that because it's such a long season that the pollen has a chance to form properly, that it's more available to the bee to pick up, or is it some other matter, you think?
Well, I'm not a botany expert or an expert beekeeper, but I mean, that sounds plausible. If the flower's flowering longer and producing more pollen, then the probability that a bee has to go and collect nectar and pollen is greater.
Fine. And the next question, Terry, if you can. What's that one? Good question, we've done that one, I think.
I've done that one.
Quality standards overseas.
Yes, there was just a question about the model of trying to compete with quality standards of honey in the international scale the best way. The unique thing about New Zealand honey is that it's a plant material with unique properties. Isn't this what we should protect and demonstrate as unique? So if we extend that, and I mentioned to someone who was talking to on the phone to earlier, is that one of the ways of solving the issue of low diacetase, high C4 sugar levels, and high HMF is actually to move the model away from MGO and to sell the honey purely as pure Mānuka honey and young. And along with any other New Zealand monofloral honey. Of course, the consequence is that the industry has been, and the market's been developed over the years based on the non-peroxide activity, or the UMF value. And so, I'm not an expert in marketing, but I would assume that it would be very hard in the future to claim a uniqueness for Mānuka honey purely on the fact that it was Mānuka and didn't have any perceived biological benefit. What do you think, John?
I think there is the opportunity for the New Zealand industry, given some of the work you've done, based on the understanding of what is bioactive on this honey, knowing this honey has more values than just an antibacterial. And a lot of that research has been coming into the fore in the background, and we've shared some very recently. So it's an exciting prospect for the industry to add rating systems that are more than just methagloxal. And it's an exciting aspect that they own some of these key markers. So, you know, if I was investing in this industry, given the science that has been done on it, and I say, oh, I could protect the term, I could protect how we rate it, and I could invest into that. And there is this journey to go down that for me is some of that answer to that question, that we expand. Yes, we grade it on Mānuka, monofloral, multifloral. Yes, we can rate it. And how we rate it should come out of how we grade it. For me, it's illogical to have them in different baskets. That creates gaps in the picture. But there is that potential for the industry. And I think that was based on the core research you did with Jonathan Stephen and Bruce and co. That was a whole international team. To do it, which we now, so hopefully that answers the question. And I think from a, not necessarily a marketing, because I'm not a marketer, but from a consumer's perspective, why do they eat this honey? During the holiday, prior to lockdown, during the holiday, I got a question from a reporter. It says, oh, John, you sell this honey on this pretense. It was an aggressive reporter that it treats all these wounds and it's got MGO in it and it's great for dosimetry. I said, well, no, we don't. We actually just rate it. We don't claim that. We just say it has this property. Yes, John, but most people eat it. 95, 96 people eat it. And they're not eating it for a winter. Well, But there is the other body of research we did with the radiotherapy ecology group that says this honey has the same effect of palliative care in terms of those people under chemotherapy for sore throats. So it was soothing the throat the same as palliative care, and that included opioids and all the rest of it, that treat. So we know this honey has these other values, and we've shared some other research that is bubbling along there behind this honey, why people eat it. So I think we can rate it on that as well. We have the potential to really grow this industry and protect it, which was one of the questions that come through. So I think that's the journey ahead for the industry, that. But back to the science side of the thing, we've been involved, you and I, we've built contacts around the world to share the science. For me, and correct me, part of the value of having them in the room, working with the same samples, working with the same science, we cut down a lot of the politics and positioning. Would you say that's been successful over the last few years?
Oh, indeed it has. It's been very important to have collaborations in China and in the UK and now in Europe. You've had those contacts which have been very important, and now being involved in those committees around the world is that we get a recognition of New Zealand wants to be involved.
Yep.
And also that we're prepared to help out on the international arena. That's been important, and we're a voice on behalf of New Zealand, and that's important as well. So if we get the science right, then we should be able to work through the politics.
Okay, 2 more questions from Lynn O'Sullivan. Is that on the chat, Kirsty?
Yes, it's on the chat. I can read it. Lynn O'Sullivan has asked, in your opinion, what is the optimal storage temperature bracket for Mānuka honey that is sold internationally?
Well, there's a lot of people online at the moment may have a different opinion to me, but I wouldn't consider going over 23 degrees. And as I said earlier, the lower the better. And also it's important to try and keep the temperature as low as possible when you're warming the drums to pour them out when you're batching the honey. If you consider putting drums of honey in a warm room at 50 degrees for so many days, because of the thermal mass of the drums, is that the outside of the drum will spend more time at 50 or close to 50 degrees than the middle of the drum. So, and then letting it cool down. So too long there, you'll get a decrease in diacetase and HMF will start to rise. So the lower there, the better. And then long-term storage, it's better to have the lower temperature.
And one question from James Jeffrey, which I think previously in my soliloquy I seemed to answer it, which was, why do we make such a big thing of the MGO content? And I think there is an emerging view with the science that is coming through. There is more to this honey than just that. We are in trouble that if it is just that, because it is available in other honeys, other leptospermins in other countries, that we do need to provide a better answer to the consumer of why they eat it. And we are able to do that and represent that in a rating system. So I think that is the future. Terry, back to you. And since the time I've known you, you've put a massive amount of commitment into this industry. Yes, you're part of a commercial animal analytica, but my time with you has been invaluable, and you've put that extra effort into the science and your commitment, and you've also stood by your scientific principles a lot. So thank you for that. Give me your thoughts with future, given that probably tomorrow we'll get a sign-off from the government over the work program for protecting the term, the science program of protecting the term Mānuka honey. So we've got a whole $3 million to be able to invest into identifying it is Mānuka, that it is Leptospermum scoparium, it's not adulterated, and it comes from New Zealand. They're the 4 key principles around the project to help us protect this term. That. Where do you see us in the future?
I think longer term, the industry should maximise the uniqueness of all New Zealand monofloral honeys. And definitely that has to be underpinned by sound science, and also that you can guarantee that the product is of high quality. So that's both stability, bioactivity, and food safety wise, it's important that it has no bacteria or yeasts, that it has no added chemicals, pesticides, and that it is authentic, so you can underwrite it by some sort of rosette or label or mark, and that it hasn't been adulterated. So they are the important things. Specific to Mānuka, I know that the program being signed off by the government will go a long way to verify that New Zealand product is authentic, and that is very important. I think we'll all agree that in the past that some of the authenticity and mixing of honeys overseas has had a major negative effect on the New Zealand industry, and if we can all think that we're one industry rather than being many within the industry trying to undercut each other, we're really protecting New Zealand Inc. in terms of the honey industry.
So thank you, Terry. I'll thank you very much. It's been thus far excellent journey. I'm sure we've got more to go. Next Monday we have Victor Goldsmith and Ian Fletcher. They will be communicating and having this chat about protecting the term Mānuka honey. That'll be quite a major discussion for the UMF Honey Association, because they've committed their heart and souls and their minds to that project, let alone their wallets. So to be able to see that, where that's gone and how the government's put support to it, and that support has been underpinned by a complete industry focus and commitment to it, which, you know, that shows that the industry is able to work collaboratively, maturity, in a mature way, and actually achieve things. So I think that's quite an outcome for the industry, and we'll talk about that on Monday.
Great.
And for your involvement prior to that and for the future, again, thank you.
Well, thanks very much. And John, I appreciate the opportunity to talk to everyone, and I really enjoy the industry. I get a kick from doing the science and talking about it. So thanks for the opportunity.
Thank you. Thank you all. And thanks for your time.